Today, our focus is on user experience for mobile apps and web browsers. The responsibility for ensuring fast user experiences is no longer just for the web development teams. Increasingly, mobile app developers are challenged to deliver experiences that better engage their audiences, even when the last mile cellular connectivity is slow and congested. Today, we are bringing in a couple of experts from our web performance and mobile teams. Our first speaker is Akhil Jayaprakash, who leads mobile development initiatives at Akamai. Akhil will walk you through challenges, best practices, and case studies for mobile apps. Our second speaker is Ted Shooter, who will walk you through best practices to achieve faster, smarter web browser performance. So without further ado, here is Akhil Jayaprakash.
Hey, thanks, Philip. Hello, everyone. My name is Akhil Jayaprakash. I'm a product manager in the Web Experience Group at Akamai. My main area of focus is on solving mobile app performance for our customers. So before I kind of dive into my slides, I would like to kind of paint a mental picture of how painful it is today for users when they actually open up your app and it doesn't respond quickly. So let me take you through a product that's out in the market. So this is Relay. It's a robot butler. They're used today to get orders for snacks and newspapers from your hotel room doorstep. Now, all of us know how painful hotel Wi-Fi can be. And due to this, one of the drawbacks of this butler is the fact that when you try to order something, all the user sees is a spinning wheel, because it's primarily checking with the inventory systems in the back end if your favorite snack is just in stock or not. This leads users being frustrated and oftentimes just abandon the operation altogether. Now, kind of put yourself in the shoe, where you're essentially that person trying to order that snack from this butler. This is exactly how your users feel when your app shows them a spinning wheel. So for example, most of mobile shopping app users open up their app when they're inside a retail store in order to compare, primarily in order to just compare prices, and they could be in a basement of the mall with poor connectivity. And that's how a user ends up being frustrated and just abandons your app altogether. So now let's just shift our focus into why mobile app performance is important compared to your mobile web. So as per Wall Street Journal last year, the average number of transactions on a mobile app is higher than that on a mobile web. This means there are more number of images viewed within a mobile app than on a mobile web. Net, what you want to take away from this is mobile apps are highly engaging experiences. Users tend to interact more on your mobile app rather than on your mobile web. So you need to ensure that your mobile app is as fast and reliable under any user scenario. Now, talking about user scenarios, the real world challenges for a mobile app is infinite. And when you look at the different challenges that users face today, you want to look at the different scenarios a user is on when they open up your mobile app. There are different permutations and combinations that can impact your mobile app performance. So let's take an example for a carrier here, right? So the time to load content over a cellular network varies based on the load on a cell tower and the network itself. So it's typical, you can observe that your app performance or the load times are slower during peak or commute hours, and when you compare that with something like an off-peak hours. So this is where we see ourselves stepping in and solving these challenges for you. So because, as a mobile app developer, you want to ensure that you focus your resources and energy in creating a really engaging application, and we help solve the real world problems or the different combinations that a user could potentially be in. And how do we do this? Like, how do we understand what's going on out in the network today? And that's where the data that we get is insightful. So today we get about 38% of all traffic that actually flows through our network are over a cellular network. We serve about 200 billion API calls and about 1.5 trillion images per day. So that itself, that gives us insight into how what are the different challenges that users face, and we are able to test our theories using the data that we see. So now, now just moving into, how do we, or what are the KPIs that we're actually helping improve for a mobile app owner? So there are three main pillars that we look at, helping for a mobile app business owner. One is obviously increasing your app installs. Second is how do we help maximize conversions for you? And the third piece is by improving mobile app performance, your users have a really good experience in your app and thus driving customer loyalty. So let me kind of double click into how do we exactly do this? What are the products that Akamai has that helps drive these metrics? So that's where, we have a suite of products that can help improve your mobile app performance. So starting with sort of the very first one, that's Ion. It's a platform on which we will be accelerating and caching your APIs. Image Manager is used to resize your images based on the device type to ensure that you provide an engaging experience across all your devices. Excuse me. With the addition of a new mobile app performance SDK, we are able to understand user situations and optimize app performance based on last mile conditions. So think of this as an extended Akamai entity sitting in your app, beaming up information that says, here's the user scenario here's the scenario that the user is in, and here's how you got to adapt, or Akamai needs to adapt content based on that user scenario. The fourth product on that list is, so this is useful for a customer who has frequent flash crowds or requires frequent maintenance in the backend. What we can do there is we can offload those flash crowds, or if you want to take away some part of your traffic and put it onto a static server, we can help you do those at the edge. And that's using our prioritization cloudlet. Now, so that's the 4 performance features. So Ion, Image Manager, Mobile App Performance SDK, and the prioritization cloudlets are focused primarily on improving app performance and ensuring reliability. The 5th item in that list is KSD. Now, if your API is exposed to the outside world and you have not just your mobile app as a consumer for the API, you have third-party vendors consuming those APIs, you want to obviously protect it from malicious users. And that's where KSD 5.0 can help you, where we essentially mitigate or detect and mitigate those malicious users for you at the edge. Now, instead of going into how each and every feature in these products work, what I want to do is I want to walk you through different app use cases and how we can help solve those. So the first use case that we have is a retail app. So this is your common application. Most users would have multiple retail applications that they use. And the key thing here is we want to know what's really important for a retail app. So the first thing is obviously improving your home screen load times. So by improving that performance for the first screen that a user views, what we can do there is by preloading the assets that's needed for that home screen. So typically, if you open up a mobile app or a shopping app, you're going to see that the first couple of content or rows in that mobile app contains daily deals or sponsored content. What we can do is we can preload that content into those users' devices so that when a user opens up the app, they instantly get that content. So you can take this even further by putting in videos in there. So every time a user opens up and they click on that first daily deal section, they can instantly view that content. The second piece is we want to ensure that the app page flows are faster. We do that by accelerating your API requests and making your API requests adapt to client-side network connectivity. So think of this as your search queries that you're running. And when a user actually runs a search query, typically your app or API endpoint responds with a list of 30 results. Now you have the ability to adapt that API endpoint with client-side network quality. So you can hint those API endpoints and inform the API endpoint that, hey, now the connectivity for this user is really low. instead of sending me the default 30, send me only 10 results. You're reducing the payload, the response comes back, it's easy to parse through, and immediately shows up on screen. The third item is really critical, and we've observed many apps not following this principle. So one of the key things that we want to highlight here in this webinar is you want to make sure your images are loading up as quickly as possible. And one of the key observations that we made when we actually looked at most of the apps out there was that most of the images are not resized, or the quality is too large for a small screen. So you typically end up serving out a high-res image to your mobile applications. And as I said in my previous slide, we have Image Manager, which can help adapt those images based on device type. So you don't have to keep track of what are the different combinations out there. We take care of that for you. The fourth item on that list is how do we free up your web server resources? So there is obviously a factor that gets into, every user transaction, there's a factor that gets involved, which is your origin think time. So how much time does your web server actually take to respond to requests? You can improve that think times by freeing up the number of requests that's hitting your origin server. And one way to do that is by caching your APIs. And when I speak with customers about caching the APIs, one of the concerns that they tell us is, all right, so if I cache my APIs, how soon can I remove that from your cache? If something goes wrong, I want to immediately remove it. And the good news is we have Fast Purge, which allows you to remove that content in less than 5 seconds. So you've got to start thinking of what content can I offload to an Akamai server, be it images or APIs, because now you have the ability to remove that content in less than 5 seconds. And for those who are exposing their APIs today, not just to the mobile app, but also to third-party vendors, we obviously can help protect those API endpoints from malicious users. Finally, when you do optimize your mobile app, as a technical owner for a mobile app and as a business owner for a mobile app, you want to see the results. You want to see how much of an improvement have we made. So what we have as part of the mobile app performance SDK is a toolkit that helps you allow to measure how much time did it take for a user event in your application. So imagine if you want to measure how much time does it take for a user to check out of your mobile app, or how much time does it take for my home screen to load up? How much time did it take for a user to run a search query and get the results and paint those images on the app? So we have tools to be laser focused on the user events that you as a business wants to observe, and then we can provide you that data. And we can be extremely prescriptive about solving those events for you. Now, I did a little background exercise on this prior to this webinar. So we actually collected, screened through most of the apps out there, and we want to see if there's any room for improvement. And it looks like, if you look at the majority of the apps in this room today, in this webinar, 80% of these apps do not speak IPv6. What this means is if you are a retail app servicing US customer base, your app needs to be IPv6 enabled, because IPv6 connections or transactions are faster on a cellular network than on an IPv4 connection. And again, this is a simple checkbox on Akamai. You have access to this today. It's just a matter of just turning this on for your API and images traffic. The second interesting thing that we found out was 54% of the apps do not have a proper use agent string. So as you can see on the slide there, there's a use agent string called OKHTTP/2.1, CF networking. These are traditional networking libraries that app developers just download from GitHub or somewhere, and they merge it into the app in order to leverage a particular feature in that library. And what typically ends up happening is they don't observe the use agent string that's going along with those requests made by that networking library. And the byproducts of that, or the result of doing such, getting a third-party library and integrating it is, if you have an image manipulation service like Scene7 or Cloudinary, it's not working for you today, because those use agent strings are indecipherable. It's just OKHTTP. Other image manipulation services looks at that data at that user agent string to identify what device type is this request coming from, and then resize the images based on that. So it's highly probable that you guys, if you have an image manipulation service today, it's probably not working for you guys. So this brings to at the end of my sort of slides that I have, which is if you want a personalized profiling of your app done, do let us know. I'll give you the links at the end of my presentation, but feel free to reach out on that form, and we'll do a personalized report for you guys. So let's look at the next use case. So we have the next one is travel and hotel apps. We have a lot of customers come to us and ask for how do you optimize a travel and hotel app? And one of the key things that they call out is my search query times are really high. So on an average, we have seen anywhere from 3 to 5 seconds being the average search query time. And then there are a huge amount of apps that's actually beyond 10 seconds. Now, what we can do there is we can, again, use our SDK to actually hint your API endpoints and informing them of how bad the user connectivity is. So now your API endpoint can actually respond reactively based on that network quality. So you look at trimming search results. You could look at optimizing your app to send lesser information so that the search engine doesn't have to do more calculations. It can just immediately respond back. The second item on that list is how do you ensure that you get faster image load times? Again, the answer is leverage Image Manager. You're able to adapt images based on device types. You don't have to bear the burden of creating image formats or image files for every device type. We take care of that for you. The third feature is a unique, one of the USPs of a travel or hotel app is providing offers. And you want to ensure that you are providing a good instant experience whenever a user clicks on those offers. And what we can do, or what Akamai can help you guys with, is we can preload that assets or preload that data into the application. So whenever you push out a new campaign, before sending those push notifications out to get those users in to view those offers, we can pre-push those assets into the app. So as soon as your campaign notifications go out, user clicks on the notification, they're instantly seeing the offers. They don't see a spinning wheel. And the last point is obviously you want to look at caching your images and APIs. Again, this talks about freeing up your origin server resources. So that's sort of the use cases, or that's how we can help for a travel or a hotel app. Again, if you look at, we did a little bit of background on, what are the travel average observations or the observations that we find in a hotel or a travel app. So on an average, you can see about 60% of apps out there take about anywhere from 3 to 5 seconds for a search query. Again, 90% of the apps don't actually leverage IPv6. Again, this is it's a low-hanging fruit. You can go in and turn this on today. The other interesting observation that we actually did was 95% of the apps out there do not leverage HTTP2. So this is a big gap. We enable HTTP2, or most of our customers have enabled HTTP2 on their web properties, but we haven't seen that happen on an app property. And the reason being is, you have turned on HTTP2 on the domain, but your app doesn't support HTTP2. And that's primarily because your developers might be using a custom networking library, or they've done manipulations in networking library. And our advice here is, have those upgrade those networking libraries to support HTTP2. This helps reduce socket time because when you open up an app, if you profile an app, what you're going to see is for one single transaction or for one single page load, you're going to see multiple sockets being created. So you have, just for api.foo.com, you're going to end up creating 9 different sockets, each socket negotiating a TCP, DNS, and TLS connections. And you could eliminate all of that and multiplex all into one request, and that's using HTTP2. So that's the observations that we did. Again, I want to close this off by saying, if you have a mobile app today and you would like us to profile and understand and recommend what are the performance features that you need to be using or what are the optimizations that you could be doing to your app, please feel free to sign up. That's the link right there. It's https://akamai.me/my-app. So if you go into that link, sign up there. Within a week, we'll have our experts profile the app and help you identify what are the optimizations that you can do for your mobile application. With that, I'll hand this over to Ted.
Perfect. Thanks, Akhil. So yeah, thank you, Akhil. My name is Ted Shooter. I'm the product manager for browser performance. So many of the items that Akhil just talked about, especially around cellular delivery, are equally applicable on the browser side. So again, those things like IPv6, HTTP2, all of those are great things to enable a better and faster browser experience as well. Today, I'm going to shift gears a little bit from our cellular and application experience and talk about some of the new things we're doing to drive faster, smarter browser performance in the area of what we're doing with learning engines and how we can apply automatic optimizations. So if you're here today, I'm imagining there's an understanding around the impact and performance. Akhil talked about some of the importance of performance from a mobile app perspective, but there's lots of great data out there what the impact on a great web experience is. So this is one of those stats around how long it takes before someone abandons the site. So I think overall, I think everyone here understands that users expect a great mobile experience regardless of whether wherever the problem may lie in the network, if that's the last mile or on the delivery side of things. Now, the reality, however, is when we talk about performance, I'm not just going to talk about that web experience, but I'm going to talk about the whole ability to get features out to your customers. So that whole pipeline between development, deployment, production, and getting those new things out into your web world. So for us, we're really focused now on faster, not just being about that web performance, but being able to get those experiences out into the market. And so what we're looking at is how can Akamai enable those optimizations, get that web performance out without impacting the work that is already on your plate. So the new umbrella of features that I'm going to talk about is called adaptive acceleration. So there's a number of features under this umbrella, and all of these are around getting faster to market with automatic optimizations. And these are all based on real user behavior. So this is around a learning engine, understanding those pages and applying optimizations automatically. So the idea of we understand the page, we can apply optimizations. Again, I think many of us in this room today on this webinar have gone through that exercise of running a web page test, looking at that waterfall, seeing what those bottlenecks are, and then making changes and updates and pushing those out, that iterative process. The underlying idea here is how can we automate that experience? And by understanding real user behavior, by leveraging the RUM data that we already have on that page, can we make those decisions automatic? So I'm going to talk about two sets of features to enable that experience. The first set of features is what we are calling automatic push and pre-connect. And this is leveraging open standards that Akamai has championed under HTTP2. Second feature I'm going to talk about is called Resource Optimizer. Again, leveraging some emerging browser standards in order to optimize that web experience. Again, all of these are around getting faster to market with these automatic optimizations that we're applying for you.
Okay, we are going to Take a brief interval here. Ted seems to have lost his audio. For all the participants, you have access to the Resources tab at the bottom of your screen, and you should be able to download this presentation. Let's give Ted a minute or so while he joins back. Also, please do not forget to fill out the survey at the end. We have probably 10 to 15 more minutes to go. Meanwhile, Akhil, there are a couple of questions. Do you mind answering a couple of questions from your end of the presentation while we wait for Ted?
Sure.
Okay.
Yep.
So one of the questions that came in was you mentioned there is a mobile SDK. Is this available to existing Akamai customers, and how can customers get it?
Great question. So the mobile app performance SDK is available today to Ion Premier and Ion Media Advanced customers. So if you are using Ion Premier today or Ion Media Advanced with Akamai, you get access to this SDK naturally. If you're using other products, you would need to upgrade to Ion Premier to get hold of the SDK. That being said, if anyone wants to do a trial, field test this, please feel free to reach out to us.
Okay. The next one it has to do with the API caching. And the question that came in was, can APIs be cached by Akamai? And what is your recommendation around best practices for caching APIs?
So that's another good question.
Oh, looks like Ted
There
came back.
Hey there. Sorry about that. It looks like we had some technical difficulties.
Hey, no worries. We were kind of taking some of the questions that had come in, and
Perfect.
Akhil was answering. We'll get back to it after your presentation, Ted. So please keep going.
Okay. Perfect. Good segue here with a login screen. So one of the challenges a lot of techniques have had in the past about understanding what a page looks like is we get things stuck in login screens. So bots that are traversing sites or other mechanisms, headless browsers trying to understand a page get blocked by things like this. Other methods included putting heavy scripts on the client in order to understand what's going and capturing that data. The beauty of using real user data, of using the RUM data that's already available on that page is we don't have to worry about any of these. This is transparent. The RUM data was already being collected on these pages. There's no extra processing required. It doesn't get blocked in by the lack of cookies or login screens. So by capturing all the RUM data, the learning engine really knows about everything that's happening on that page. So this includes what are the resources on the page, what is the order that they're loaded, how long did they load it, how long did it take to load them. And we see this across different devices and different geos. So we can take all of that data and start making smart decisions on what we can apply to that page. So a simplified view here of users across the internet hitting those edge servers. So all of that data, all of that RUM data being collected again across desktop, across mobile users, and we're building a picture of what that site looks like. In fact, we can do that at a very quick pace. So we can continuously look and see what's happening on those sites in short increments. So every 15 minutes, look and see what's happening, which are the most popular pages, has any of the content changes, have there been any updates to those sites. And so what we're doing in the learning engine that we're deploying is we're looking back 12 hours. So we're using a moving window and looking over that 12-hour period to make decisions. And by doing that, again, we can make decisions around what optimizations we can apply for that page. So we're collecting that data in the adaptive acceleration learning engine, building that waterfall, deciding what we can apply to optimize those pages. Now, under adaptive acceleration, those optimizations are being applied at the same spot that the users are interacting with the page. So this is what we call the edge. So they're interacting at the edge here, and we're applying seamless optimizations based on open standards. Again, things that we have championed as part of that standards community. So these are HTTP2 push So applying this right at the very last second as the user is requesting the page. And we're also using the W3C resource hint pre-connect to drive third-party connections earlier. So these are happening right at the edge in this first set of optimizations. And so there's no change to the content, no changes at origin. So again, these are all optimizations that we're able to determine based on understanding that page from the real user behavior on that page. So I'm going to dig into a little more details on what those optimizations look like. And again, so pushing resources during the idle period. So this is the idea where a user requests a page, and for dynamic personalized content, that page has to come back from origin. So going across the internet on our optimized path back to the origin, that page is getting created, the origin infrastructure returning that page and coming back to Akamai, and then we're serving it over that last mile. That whole time while we're doing that, that network to the user and the browser is sitting idle waiting. And so this is an ideal time that we can do things in advance of that page coming. And that's what we're going to do with push, and I'll dig into that. The other one is around pre-connecting the third-party content. As Akil mentioned earlier, reducing the number of connections, there's a fixed cost to every one of those connections that needs to be created. And by doing that off the critical path, we can minimize the impact of those connections. So let's take a look. This is a very simple waterfall view, a linear timeline. So again, at the beginning, we have that period of time where we're waiting for the page. That page normally comes into a browser, and then it fires off a bunch of requests for resources for things like style sheets, fonts, scripts, and images. So this is sort of a simplified, normal process. The idea of push, again, for that dynamic, personalized content, we can figure out what are those critical resources right at the beginning that are needed to render their page. And we can pull those out in that nice window of opportunity while we're waiting for the page. So this is accelerating that time to first byte. So instead of waiting for that page to come back, we can drive those resources into the browser right away. And by focusing on those critical resources that we saw in the run data that impacted that render experience, what we're able to do is accelerate to see meaningful things on the screen sooner than previously possible. So again, this is around pushing using HTTP2 push, done automatically for your users based on understanding that page via the run data. The other piece is we look at content that may be coming from a sharded domain or from a third party. Each one of those has a fixed cost to connect to those. When we talk about HTTP2, what we need here now is DNS lookup, as we always do, TCP, creating that connection, and then securing negotiating the security for that connection. So all of this is done as part of pre-connect, and we can actually do that right at the beginning before it's on the critical path. So if we go back to this idealized timeline, we're seeing all of those pushed resources and then firing off the pre-connects. And all of this is happening in parallel as other assets are being downloaded. So this is happening when it's not on the critical path. And ultimately, again, that's improving that rendering experience. You're not seeing that happen as part of the critical rendering period. So this is automatic push and pre-connect. This is the first feature available under the adaptive acceleration umbrella, all being fired off based on understanding what that waterfall and what that page looks like. This is available today and can be turned on any of the Ion products. I'm going to talk about the next one. This one is also now available in beta. It's called Resource Optimizer. So again, with this nice window of opportunity that we have to push resources, if we can make those resources even smaller, we can push more information in that period of time. So Resource Optimizer, similar to what Image Manager that Akil was talking about for images, is going to automatically reduce the size of those critical resources that really contribute to that web experience. So what we're doing is we're looking at those style sheets and those JavaScripts. These are the two resources that really contribute to that early rendering experience. So looking at the style sheets and JavaScript, how can we make those smaller so that we can, again, push them and get more performance? So what we're doing, again, completely transparent to your origin infrastructure, is we're using two new compression algorithms to reduce the size of those resources. The first one I'm going to talk about is called Zopfli, and if you haven't heard about these before, these are named after Swedish pastries. Zopfli is completely compatible with existing compression, so there's no new browser support needed. It's completely compatible with gzip zlib. And what it does is it does reduce the size. It makes those files smaller by 3 to 8%. In our test on real customer sites, what we're seeing on average is 5%, pretty much in the middle of that range, the advertised range for that. The downside of this is it can be 80 times longer to compress these files. So while the decompression is exactly the same, the compression takes a lot more time. So what we are able to do is take in your resource, however it is compressed today, and then as we cache that resource, we will then apply Zopfli to it and make it smaller in cache and for all of the customers that are then requesting that resource. Again, no changes needed at the origin infrastructure. We're just taking in the file as served and making it smaller by 5% using Zopfli. And again, Zopfli is supported by all browsers as it's compatible with zlib and gzip today. Another Swedish pastry compression algorithm here, Brotli, which you may have heard of as well, is driving even more compression. And so again, up to 25% at Brotli 11. Brotli has multiple levels of compression, 11 being the maximum. We're seeing the most impact. Again, in reality, we're seeing about 15% in average on most pages. So that is reducing your file sizes on top of the gzip. So it's 15% improvement over gzip. With Brotli, there's a new encoding type, BR encoding type, and so that means new file support, new browser support needed for these compression types. We see it in most browsers today, so good browser adoption. And when we don't have Brotli support, we can fall back to delivering the Zopfli version of that. So with Brotli, again, reducing the file size around 15% over gzip today. And again, nothing needed on your end of the infrastructure. So we take in your resource as delivered, as compressed. We create a Zopfli version and a Brotli version in cache, and then we deliver the smallest one possible based on browser support. No other changes needed on your end. If you need to update cache, purge, all of that happens based on the original resource. So it's completely transparent from an optimization perspective. Pulling this all back together, this is where we left off on the automatic push and pre-connect. And this is the idealized timeline of pushing resources in that period of time. So again, just a complete thought here, what we're able to do is make those resources smaller all the way along and drive more value and more impact on that early web experience. All right, so let's look at an example here. I've chosen the Canadian site, a very Canadian site, obviously created to show some of this technology. And so the defining elements of this page is with lots of big images, a lot of resources impacting how the page appears. It is a personalized page that comes back from origin, so there's a period of time where we would normally be sitting idle. And so by applying Resource Optimizer and the automatic push and pre-connect, we're able to optimize the site. In fact, I also have Image Manager turned on for this site so that we're optimizing those images as well. But focusing on the Resource Optimizer side, here is a quick look at what we're able to do on those files. Again, this is over gzip. So we're able to take all of those JavaScripts and style sheets and compress those anywhere from 8% to 25%. The average impact here on this particular page is almost 14% improvement over the original content. So again, this is driving these this early web experience, of course, reducing the bandwidth usage for your cellular metered connections. So to wrap this up and conclude here with the adaptive acceleration, what we're able to see with automatic push and pre-connect as well as resource optimizer is we're able to improve that first byte, so the time that it takes for that data to get into the browser, at least 35%. In fact, we see significant improvement, as you can imagine, with push on that first byte arriving in the browser. We're seeing 15% improvement via Broadly on the file size for those critical resources, and we're seeing around 5% improvement on that start render. So that time it takes to see a meaningful draw on that screen is improving by about 5%. Again, all of this is being enabled by a learning engine based on the run data that's already enabled on your page to understand what's going on that page, what are the resources needed, and able to apply automatic optimizations. And to understand what is actually happening on your page, there is a new report. For those of you who live in Luna, you're able to bring up the adaptive acceleration report to see all of these optimizations that are being determined. So you're able to see what's being applied across the property as well as on specific pages. You're able to search for specific resources or search on specific pages. So you're able to see what's going on, and all of this is API accessible as well. And again, this is all available today. So adaptive acceleration, automatic push and pre-connect is available today. And Resource Optimizer is also available in beta. And to get any of our ION beta capabilities, you simply need the ION beta channel added to your contract, which you can do via the marketplace, or reach out to your partner, sales manager, and they're able to walk you through that process. So I do encourage you to turn on both of these. These are very simple on-off configurations, as you can see from the behaviors. You simply add them and leave those toggles to on, and you're able to achieve this today. And if there are any questions that come up, any interest that you have on this, please feel free to reach out to the team driving this at A2 at Adaptive Acceleration, A2-beta at Akamai.com.